Hopefully everyone gets a seat. Full house. Really nice to see you all. Welcome. We're going to listen to Going for a Ride with the Azure Service Bus by Nikos. Yeah, I'll let him present whatever he's going to speak about shortly. We have a small agenda. We're just going to meet and greet offline. We already did that. This is the intro. And then Nikos will present. And after that, we'll eat pizza, drink some beverages, and talk some more, mingle. So, Azure Skåne, that's us. And we're all about learning, networking, and having fun. And everyone's welcome. You don't have to have any prior knowledge about Azure. I mean, it's of course fun if you work in the field, but you know, everyone's welcome. So, welcome. Azure Skåne crew. It's me, it's Goran, it's Magnus. My name is Michael and I work for Microsoft. Goran is an Azure AI MVP. He works for Pandora. And Magnus Mortensson, he's an Azure MVP and a regional director, and he works independently, I think. He has a lot of interests in the area, at least. This is something we threw up in the intro just to let the people online know, because we saw that people not from the area started to attend. It's more like to show that we're down there, here, if you're curious. So, if you attend this and if you're active on social media, please follow us. And if you tweet or post anything, use the hashtag. It's always nice when you go into the hashtag and see what we've been up to and what we've been learning about. So, please follow us. And as always, we're collaborating with Foo Café. It wouldn't be possible without them, so big thank you to the sponsors. This one I showed earlier to the people here. The people online, you're also free to claim this NFT badge. If you collect a lot of these badges, you can actually go online. There's a map showing who owns the badges, where and stuff. If you opt in for it, it's not default. But the idea is eventually, if you go to a conference and show I have these badges, I've been a really good Azure learner, or an inclusive leader, or content hero or something, you probably would be gifted something cool. Sometimes they send out stuff to you also. Happened to me once. If you're in the field, if you have something to share, if you're interested in speaking, this is a really good, safe place to do that. If you've done it before, fine. If you haven't done it before, also fine. If you want to try it out, this is the place. So we have an open session eyes. Otherwise, just reach out to us directly and let us know. So don't be shy. If you have colleagues, poke them and tell them to submit. When COVID hit, we did these meetups, but there was empty space here. There was just a camera, so we felt a little bit disconnected. We started this Discord, and I use it day to day. There's a lot of good stuff. It's connected to all of those Azure news, so if there's a service outage, Discord lets me know. If there's a new service for a public preview or public preview, Discord lets me know. If I have a question about Service Bus, Nikos will tell me what I need to do on Discord. So please join it and stay connected. And that was it. Let's get started. I'll hand it over to you, Nikos.
Thanks. Is the mic okay? Sounds okay. Just give me a moment to wake up the beast. Yeah. Looks good. Aren't we? Okay. Good. Well, first of all, thanks a lot for joining my very first public session. I'm honored. I really like that amongst you I see many former colleagues, forever friends. Thanks a lot. Thanks all of you for coming. And now that we're done with the shenanigans, let's get nerdy. So the service bus. First of all, it's not a bus. Let's start with that. But before taking the bus, a few words about me. My name is Nikos. I work as a senior cloud engineer and cloud evangelist at Hello. I have a few certifications because I like Azure a lot. And I also have a blog where I write mostly about Azure. I do a podcast. The first episode is going out soon. And I try to be active in communities like this because it gives me a lot. And I hope I can share my knowledge with all of you also. Now, what will we discuss today? Well, first of all, I will explain what is the service bus, which, as I said, is not a bus. Then I will also compare it with the Event Grid and Event Hub, which are two resources of the same family in Azure, but they have very clear differences, and I will try to explain them. Then I will show you how you can use Service Bus in your architecture. I will explain the first in, first out pattern, how to implement this with the Service Bus. I will also show you how to send scheduled messages, and what is the dead letter queue, where the messages go to die, and some pitfalls to avoid. Okay, some basics about the Service Bus. The Service Bus is a message broker, like Kafka, like others. It is used to send messages, and we always have a sender and a receiver. And just as the Microsoft Learn states it, Azure Service Bus is a fully managed enterprise message broker with message queues and publish subscribe topics in a namespace. The namespace is a grouping. So what you create in Azure when you create a Service Bus is actually a namespace. And within it, you create queues and topics. The Service Bus is used to decouple applications and services from each other. I will show you later an image that explains it a little bit better. It is one of the oldest services in Azure. It has been over 10 years in Drift, and they have only missed 7 messages. That's quite a lot, if you imagine. In 10 years, there's like trillions of messages they have managed to deliver or to send in the dead letter queue, and they only missed 7. Now, with my luck, I might have one of those. But yeah, I think it's quite a few. It's quite good numbers. Of course, it's not completely free to use. There are some limitations and quotas, like the maximum message size is 256 kilobyte in the standard tier. There are 3 tiers: basic, which is actually only for development purposes. You cannot use it in production. It only has queues, no topics. It's only for development purposes. We have the standard tier and the premium tier. Obviously, the premium, the higher you get to tiers, the more expensive it becomes. Actually, it's totally different pricing models. We'll talk about them. But there are also other limitations, such as the message size, which is 256 kilobytes for the standard, 100 megabytes for the premium. Now, I'm not really aware of a scenario where I would have a 100 megabyte message, but I guess somebody needs it. Then the queues and topics are not endless either. In the standard tier, they can be up to 5 gigabyte. Now imagine 5 gigabyte of messages being 256 kilobyte big. It's really, really many. And then the messages do not go into the queue where the topic can stay there forever. The thing is that you create them, you send them, and then someone is going to pick them. So 1 gigabyte is really many messages to have in your queue. And it can go up to 80 gigabyte in the premium tier. Now we have one number of 100 messages per transaction. A transaction is the connection between an application and the service bus. So if you are bombing service bus, you can bomb it up to 100 concurrent. And then topics and queues per namespace are 10,000. Now, more than 10,000. Again, I cannot think of a scenario that needs that. But if you do, just create another namespace. You get 1,000 more. And also, those images show exactly what I said about the queues and the topics. There's a very distinct difference between them. A queue is like we have a box where I put a message and someone comes and pick them. And the topic is like an area, a forum, where I say something and multiple receivers get it. You could have like, for example, a receiver that is a logging mechanism that will just log everything we receive. Then we have other receivers who are only interested in a specific subject or message. And yeah, so on and so forth. A bit more about the Service Bus. It is directly interconnected with, integrated with the event grid, with Logic Apps, with Azure Functions, Power Platform, Microsoft 365, Dynamics 365, sorry, and Azure Stream Analytics. This means that those Azure resources have already all the connectors ready to talk to the Service Bus. Now, if you have something else, which many of us have, for example, API management is one feature we have been waiting for a long time, and I hope they deliver it pretty soon. Then you can talk to the Service Bus using their API. So the Service Bus exposes an endpoint, which you send a post request with your message, and it's exactly like sending a message from any other integrated service. It's polyglot. It speaks C#, Java, C, C++, Python, PHP, Go, JavaScript, Rust, Ruby, I think, and a number, and a few others. It is fully managed by Microsoft, and this is an important one, because as I said in the previous slide, they have only lost 7 messages in those 10 years, and this is not easy to implement by yourself, because it can happen that the hardware, the infrastructure where the Service Bus is running, for some reason goes offline. They guarantee that the message will be delivered, will be received, and then will be delivered. And they're doing it by having redundant servers, by copying the messages to multiple spaces. It is their way, and it is something that makes Service Bus an industry-leading, reliable, and available service. In all the projects that have been included, more or less, the Service Bus has been present. Now, let's talk about the differences with the Service Bus Event Hub and Event Grid. Now, I will start from the bottom. You use the Service Bus if you have a case scenario where you need to publish something. Something has happened, an order has been received, and an order needs to be shipped, for example. And if this was a topic, then the logging mechanism will log the order. The factory that will collect the items will pick the order and try to send it. The shipping company will know that we have to send an order from there to there. So multiple subscribers, multiple recipients are interested of the same message. This is when you use Service Bus, like one scenario. The Event Hub, this is mostly used with IoT projects. It is a really volume-sized service. And you use it just when something happened. You have a sensor that can do anomaly detection. You have a sensor that collects temperatures and humidity and others, and you need it to send information every second. Now, this is a lot of data, and in that case, since you're not interested in what happens next, you're not interested in that someone comes and collects it, you just want to get out with it, then Event Hub is a good resource to use. And of course, we have the Event Grid, which is totally opposite than the other two. The other two have a pull, a push-pull. I send a message, someone receives it. The Event Grid is different because someone pushes the message and makes sure that the message is delivered. So this is the big difference. Nobody has to come and ask for the message in the Event Grid. The Event Grid will deliver the message where it is supposed to be delivered. And of course, I have in the middle some text also, which pretty much says what I have said. This is also another difference that differentiates from Event Hub or from Event Grid to Event Bus. If you have multiple subscribers, directly Service Bus. That's an easy question. And Yes, of course. Event Hub is also partitioned, meaning that you have a number of, I won't say servers, you have a number of places where the messages are sent, and they can be sent in the way that you prefer. You can prefer to send all the messages in one partition, or you can prefer to send all types of messages in one partition, or you can follow round robin. Round robin means that if I have 4 servers, then the messages coming will go 0, 1, 2, 3, 0, 1, 2, 3. This is a round robin sending. Now, my favorite part, how to use Service Bus in your architecture. As you can see, I have put it in the middle, because for me it's a very central point. Imagine what would happen if we didn't have the Service Bus. I didn't write text, but I hope that everybody recognizes the symbols. Everybody's crazy about Azure like me, right? Yeah? So this is a storage, an Azure storage, where we have files, blobs, containers, queues, tables, everything. And every time something happens, like every time a blob is created, an Azure function gets notified about it. It puts it in a message. It sends it to the Service Bus. And then another function is going to be interested in this message. It's going to take it and send it to the data factory, which will then, yeah, it can do various operations. It can aggregate, calculate, do filter it out, filter it in, do anything, and put it in another place in the database, or create another file, or inform someone. Then in this scenario, we have a logic app. Logic apps are very popular nowadays. I hope many of us are using them. And they are very, very easy to create, very quick to create, and very simple. And logic apps are directly integrated with Service Bus. So if you have an incoming request, which is coming to an HTTP request, for example, which is coming to the logic app, then you make a message out of it, in with it in the Service Bus, and it goes its path then. Of course, we have the API management, which is different. This is not directly integrated with the Service Bus, but it can speak to Service Bus via the API. So we send a message with the body. The API puts the body in a message, and it sends it to the Service Bus. Now, what would happen if we didn't have it? Then all those things would have to speak directly with each other. And if one of them is down, then we have a single point of failure. We cannot commit our message. We cannot send our message. We cannot. If this was an order created, and we wanted to that this function would take it and put it in another, I don't know, server or something. If this is down, then the order is never saved. This is very serious. You need someone you can trust in the middle to collect the messages and to make them available for those who are interested. Now, the awesome demo time. Do you have smartphones? Anybody interested in testing that? Oh, where is that? Here it is. Okay. So, oh, sorry. Of course. Of course. Oh. There you go. So I will show you the code of this later, but what happens is that when you scan the QR code, you go to a web page, which is not a web page, it's just an endpoint, which triggers a function that generates a random funny name. I hope you find it funny. And then it is sent to the Service Bus, and then I have another function which picks the name and prints it in my command prompt there. So what I want to show you is what happens if I close it. Please feel free to continue to refresh the page. I believe that you will see more funny names, so it still works fine. But what happened to the messages? Where did they go? I believe you see the same screen I see. You do. So this is a namespace. Nothing weird about that. And this is my Service Bus. I have a topic. The topic is called SPT default, because I'm very creative with the names I use. And we have the Service Bus Explorer. This is a feature that was in preview mode up until recently, and they have released it in production quite recently. Now I have to pick a subscription, and hopefully, oh gee, somebody found my, okay. I didn't expect them to be that many. You really gave it a go, okay. So yeah, you see that the messages have been here, and since I'm already there, I will show you that the messages have states. So when we have sent them, they just exist in the queue or in the topic until somebody picks them. And we can pick, meaning that we can see what is in the message, but we don't really receive it until we receive it. And when we receive it, it disappears from the queue. So it is important that, of course, for our reasons, we might want to see what is coming first before processing it. But to really process it and to make it disappear from the queue, you have to receive it. So now I did pick. If I change mode and I go to receive mode, which I want, it will the messages will disappear. What I will do instead is that I will run my function again, hoping, really hoping, yeah, that it works. And as you can see, the moment it went online, it picked the messages. And now they are received, meaning that they have disappeared, hopefully. I truly hope that, yes, 0. They have all been processed now. So yeah, I believe that's a cool thing. Let's continue with the first in, first out scenario. I believe that everybody knows it, but you know, one of the very first concepts we learn when studying computer science is the first in, first out, and the last in, first out queue. And yeah, just to mention it, the first in means that the first message who came is the first message we will read, and that's like a queue in the supermarket, where the first person in the queue is going to pay first. And the last in, first out, it's like the plates that we wash. And the last plate you put on the top of your stack is the first plate that you will wash. So the first in, first out scenario can be implemented in the service bus in a kind of a dummy way, because it's not really implemented. They have a trick. The trick is that you use session. By using session, a service bus understands that, okay, messages with the same session belong to the same queue, and they will be delivered in the order they come. So in this example, we get first 1, 3, 4, 2, and you see 1 is delivered first. Then we wait, nothing else is delivered in the orange queue. 2 comes second, it goes to that guy. And then the purple, we have no subscription for that. And then we have another orange, and it will be delivered there. So this is how you implement first in, first out with service bus. It is used to implement the request respond pattern also, because one thing I didn't mention is that when we send messages, the sender gets no notification about the message and if it has been delivered, if it has been processed. It's just fire and forget. But you can build this functionality by using the request respond pattern, and you do it by putting an opposite service bus in the other side, where you send a message with a session, and then you have a trigger waiting for the service bus to respond with a message of the same session. It's like a receipt. So this is the way to implement it. I believe that the guys in Microsoft, Mikael, you can ask your colleagues, they can implement it in a little better way or a simpler way. Then we have the schedule messages, and there are 2 ways to schedule a message. When you create a message, actually when I say create a message, I mean programmatically, when you do it with code, because you can also send a message with via the portal. But when you do it with code, you can put a value in the variable called schedule and queue time UTC and send it via the regular API. I will show you the code. Or you can pass the message together with the schedule time and use another endpoint. I have them right here. It's nothing really big. Can you see? I do hope so. So here we have a message, service bus message, and as you can see, we create it and then we put a value, daytime now plus 1 hour. We put a value in the schedule and queue time, and then the message will not be delivered until this time comes. And we send the message via the regular API, send message async, or we can create a usual, a regular message without any extra values, and we send it using the schedule message async. So this is the regular message we created earlier, as you can see, and we send also the timestamp when the message should be delivered. The dead letter queue, where the messages go to die. Now, when we had those receiver functions that were triggered by a message arriving in the service bus, when they receive a message, they process it, they do something with it, and the moment the function completes, or the code completes, the message is marked as processed, and it disappears from the queue. But if an exception happens in the middle, if something goes wrong, then the message is not processed, and it will be put back in the queue, and it will be processed again. It will try again and again and again until a number of retries. I think it's 10 by default, but you can for sure adjust it. And there are also other things that can make the message to die, to go to the dead letter queue, which is that the header size exceeded. As I said, we have only 256 kilobyte for a message, and if we exceed it with the extra metadata that the message has, then it goes directly to the dead letter queue. Throwing an exception, message cannot be sent, so it's not even in the topic, it's not even in the queue. The time to leave can expire. It is a measure to protect us, because as I said, the service bus space is a few gigabytes, 1 gigabyte to 5 or 80 if you're in premium. The messages have to have a time to leave, and it's usually 14 days, which is quite a lot. But it still can happen that the message is not processed until then, because the receiver is sleeping, or because the receiver ignored it, or because we didn't have a subscription to take it. Then after this period is over, the message goes to the dead letter queue. The session ID missing will cause the message to be sent to the dead letter queue. And I talked about sessions earlier. What I didn't mention is that if a queue or a topic is marked as a demanding session, as a session queue, session topic, then all the messages need to have a session. If a message doesn't, then it goes to the dead letter queue. Then we have a max transfer hop count, because the messages can be forwarded to other topics, to other queues, and you cannot do it all the time. There is a max limit of 4 hops allowed, and there is the max delivery count. The first scenario that I mentioned, when we tried to process it and we couldn't, then we have a number of retries, and after that, the message is dead. The dead letter queue is a queue that is created separately, but it belongs to the service bus. So it's a usual queue, and we usually have a way to handle the messages going there, either sending an alert, telling that something went wrong with this message, maybe you need to look at it, or by having another trigger, picking those messages and sending them back where they can be reprocessed, or we can try programmatically to find what's missing and add it. Yeah, it's a very useful feature. Now we have a few pitfalls, and I am close to the end. The first I would like to mention is the API connection limits. I had an issue about that recently with our client. Logic apps can talk to Logic apps, and Logic app can talk to Service Bus and to other resources, and all those things are connecting using connectors. And those connectors have limits. There is a number of connections, of consequent connections you can send per minute, or per month, or how many at a time you can send. And we have to use them smart, because if we don't, then we will be out of them, and we will have throttling issues. Messages will start queuing, and they won't be sent, and we want to know why, and it is not a thing we would like to happen. How we solve this? By having multiple connections. So when we design those components, when we put them in place, Azure asks us, okay, which connection should I use? If you use the same you used before, then you share your connection with another, and then you share your limit with another. You can use multiple connections, and by this way you avoid this situation. Only text, no media, obviously. I know that sometimes we need to send messages containing images, videos, big files. If you have this scenario, then upload the files separately, someplace, get its ID, and put the ID in the message. We do not send. I know we can convert them to a base64 string. We can do many things. We can stream it, but since we cannot guarantee that the messages arrive in the order we sent them, it will end up badly. So the way to do it is you upload the files separately, you get the ID, you send the ID with a message. Then, if you need low latency, then you need to pick the premium tier, because the standard tier is shared infrastructure, which means that if another client is using this infrastructure quite a lot, then they will get the better part of the resources, and the messages will go from 15 milliseconds to 1 second. I mean, even 1 second is quite a little, but it is a very big increase, going from 15 milliseconds to 1 second. And there are clients who send 20 million messages per second, so that's quite a lot for them. By picking the premium tier, you have dedicated infrastructure, you have all the bandwidth for you, all the throughput for you, and you can guarantee low latency. There is no emulator yet. This for me is a problem. It is a problem, because when you develop your solution, you want to see how the service bus will react. We have the same thing with the Azure Storage Explorer, for example, where there is an emulator. We have the Azure Functions, where there are emulators. We can do whatever we want with them. But with the Azure Service Bus, we rely on the very service bus existing online. Now what they have is the basic tier of the service bus, which costs very, very little. It's a pay-as-you-go consumption layer, and I think, yeah, I know that it only has queues, so it's a very poor type of service bus. You cannot do a lot with it. But not having an emulator means that you have to have a real service bus which you develop your code with. It is a single point of failure. If we go back to the architecture, it's pretty visible that if this disappears, then we have a very, very big issue. But there is no scenario where you can be total bulletproof. That is 100% sure. Service bus is a very resilient, a very almost 100% available service. They claim that they never miss messages. It is considered to be safe, but what I can see is that there is a single point of failure in the middle. So maybe you need to take it into consideration and have a plan B. So what happens, what do we do if service bus go down? Maybe have geo redundancy, maybe provision another service bus in another region, something. And the last one is the zero trust. Yeah, I want to show you something. Actually, I won't, because this is on YouTube and someone can take a screenshot. But I will tell you that I have a connection string which I use to talk to the service bus, and I take it from settings. And the connection string came directly from the namespace, a shared access policy. So I used, oh God, no. So, you didn't see it? Yeah. I used the connection string belonging to the root managed access key. Obviously, I will delete everything after the demo, but yeah. This is a bad practice. We shouldn't use SAS. We shouldn't use such types of tokens. We should have an identity somewhere here, which means that there is no password, there is nothing. We take the identity and we put it to the other resource that uses it, and you say that you two can trust each other. This should be the way we did, and I think that they are about to deliver such a feature, if I'm not wrong. But if you have to do it, then try to do it as little as possible. So if you will use a SAS, then make a sender that only can send, and make a listener that only can listen. I won't do it now. And even better, why give a SAS for the whole service bus? Why should I be able to send to all topics? You can put it in the topic level. As I show you, I have here, this is my topic, and I have shared access policies here as well. So you can restrain it to a pretty good level. Of course, it's still a SAS token. It can be committed up in a Git repo, and then everybody has it. But you can rotate the keys. You can have a runbook that deletes it. You can do quite many things to defend yourself. And one other thing is that you put it as low as possible. Like, give as little access as you really need for each scenario. And this was the last one. Thanks a million for attending my first talk. And if there are any questions, comments, feedback, positive feedback, yeah?
Hold on, I'll give you the mic.
Okay.
We're talking about topics and the receivers.
Yes.
Topics, there can be many receivers.
Subscriptions, yes.
Yeah. So how do the message know it's processed? How do the message know it's processed if it, for example, received from processed from one receiver or one subscription, but the other ones?
Oh, each subscription has the message for itself. So the message will be delivered to each subscription. So it can be processed for me, but it's still unprocessed for you.
Okay, so if I have 3 receivers, then it becomes 3 messages.
Yes.
So yeah, great.
If you have, you can have multiple instances on one of the receivers.
Yeah, of course. Yeah.
Mm.
So
Yeah.
it's a bit
Yeah.
more than that. So, and of those 3, let's say you have 3 receivers, 3 instances consuming on one. I will repeat it. What I said is, like, when you have a topic and you have 3 subscriptions, within a subscription you can have multiple instances which is consuming that, and then it's only being delivered to one of the instances.
Mm.
But in the other subscription,
Yes.
it has been delivered there. So be a bit careful with that. And then it's based on the consumer, what it returns back towards the subscription, if it was successful or failed. And there you can in principle say to try again, because I had a temporary failure to another resource I tried to reach, or they say, this is wrong data, stop delivering it. So it's the consumer that controls what's happening.
That is very true. Thanks a lot. And I had this very issue when I designed the demo, because as you can see, I have all my functions in the same file, and I deployed all of them to Azure. And amongst them is even the receiver. So when I was testing it, some messages I got, and some messages I didn't. I go, what's happening? Like, why do I get only some of them? And it was because the receiver in Azure sometimes got lucky and got a message before me. So I disabled it, and now it worked fine. Yeah? Any other questions?
It's maybe a bit of a tricky question, because
Yes.
it's a topic where I'm burning for,
Yeah,
and
please.
what I'm trying people not to do.
Okay.
And you talked about first in, first out.
Yes.
Can you describe a scenario where you would use that as an architect?
I'm not sure I would use Service Bus for a first in, first out scenario, because as I mentioned, you have to do this with the sessions, and I don't like it very much. and to do the response pattern, the request response pattern, when you have to know if the message has been processed, then you have to have another service bus. And then, in my mind, it's not the way it should be to implement a first in, first out scenario. But if you have one, I'd love to hear it.
No, I'm just telling everybody don't use it. And if you go back a couple of years, you look at GCP, their piece pops up. They didn't have a guarantee of order. That's what is often being described. And GCP had a statement there stating like, if you need it, you do something wrong. Now they introduced a new pops up and a pops up light, and they have implemented order on the bus, and they took away that message. Why I'm asking it is because there are some scenarios, but normally people that think they need first in, first out, they forget that they are only guaranteeing the order the message is delivered towards the consuming party.
Exactly.
But it doesn't mean that you can guarantee the order how it is processed.
Yeah.
So if I, for example, have created a resource in a database and delete it, I might be deleting it first and then creating it because it's processed in that way, while it was delivered in the right order. So my question actually was more, be very careful making use of this first in, first out, because it will burn you when your system starts to scale. Unless you guarantee that you have only one consumer, but then you lose all your horizontal scalability.
Yeah, and how can you guarantee first in, first out when you have the internet in the middle? There's a million things that can go wrong between the sender and the receiver, even if the receiver is service bus. Latency, throughput, the antenna goes down, many things can break the pattern. So yeah, I would try to avoid it as well, yeah. Thanks.
I have a question.
Yeah.
So, can you give us some live examples where they use, like live applications where they use Service Bus?
This was one, the demo.
The demo was one, yeah. Is that in production?
Kind of. You mean to show you or to tell you?
No,
So you a bit
please,
difficult.
yeah, if you can show, sure. Go ahead. We have.
I'm not sure I'm allowed to disclose.
No?
But
Then don't show.
yeah, no. But most scenarios I have used Azure Service Bus with is to ensure that we need something to happen, and it's not done by us. So we ask Service Bus to make sure that this thing happens. So many tickets have to be created for public transport, for example, and then we don't talk to the ticket creating service directly. We ask the Service Bus to make sure that it orders 100,000 tickets for us, and Service Bus will make sure that they get delivered. Yeah, that's a scenario. Yeah, absolutely.
So when it comes to integrations around Dynamics 365, we have inbound integrations when you have data imported, and you have outbound scenarios where data is extracted out of Dynamics, ERP or CRM solutions. And of course, for outbound scenarios, you can set up, I don't know if this mic is on.
Yeah, I can hear you from.
All right, that's cool.
Yeah.
All right, okay. So for outbound scenarios, sometimes you would like to extract data out of your ERP solution based on some business events. For example, when an invoice is issued. And in those scenarios, you can set up different business events that generate their own topics. And then those topics could be sent to the service bus, and you can have different Azure functions or microservices processing the topics and transforming it into the format that the data consumer wants to enjoy.
Yeah.
Yeah.
Very good one.
So we build a lot of these integration platforms around Dynamics 365 on Azure. Yeah? Yeah.
Fantastic.
You want to have the mic back?
You want an example of not to use it?
Example of not using it. Yes. the scenarios where I would prefer Event Hub, for example, is when you really have to bomb the messages, and that you can't guarantee that they will be processed at a certain time. So if we, I had a scenario where we had a ship, a real ship, going from Belgium to South America, and throughout the trip we could gather information about the humidity in the chambers. This created trillions of rows in the database, and we would only be interested in the aggregated results. So we needed to know what happened throughout the whole trip, how it affected the products. It was bananas, actually, real bananas in the chambers. And we wanted to see how the humidity affected them throughout the trip. So now that I remember, it's from South America to Europe. And in this case, we want to send the data to a place that it is collected, and you only process it when everything is there, and it can grow a lot more than 5 gigabytes. So when we have big volumes, when you need to partition your data, I would prefer Event Hub instead. That's a scenario.
A question to that one.
Yeah.
Was the ship connected the whole trip?
Yes, it was. It was. Of course, we thought of the scenario of keeping it in the ship. Like, why do we need to have it in the cloud in the first place if we're not going to process it? But for some reason, they were very, very insisting about having the data real-time sent. Yeah.
No more questions?
Thanks a lot again. And you can contact me or get in touch. I have all my information behind this barcode, QR code. Thanks again.
Okay, thank you, Nikos. And I guess we have some time before pizza comes. You went through it too fast. Sorry. But yeah, there's more drinks there, and let's talk about Azure in the meantime.